see some of the commands, how it works and application runs. So we will start what and why high performance computing is required. So it is mainly we are using in a distributed computing, a distributed cluster. So we need to understand the different some terminologies like nodes, clusters, data centers, and all. Cluster is nothing but a group of machines or a group of nodes or a group of hosts. Different names are there. So these clusters in HPC, right? There are thousands of nodes or machines. Each and every machine is connected to each other, thousands of machine, and so we think it is a huge computer. Actually, it is a group of computers which gives us a huge computation power. So if you want to calculate something big, you need big computation power. So you need big computer. Big computer is known as a supercomputer, right? Supercomputer. Supercomputer is actually the cluster group of thousands of machines. All machines are having CPUs, right? Each machine is having 10 CPUs, 100 CPUs. So for me, whenever I'm looking at HPC perspective, all these computers are looking like a single computer which works on my problem and gives the solution. Yeah. Any questions on this? Okay. So we have thousands of machines which has a lot of CPUs, memories and all, right? So for the computation, we need CPUs, GPUs. GPU is a new one, right? From NVIDIA, graphical processing and all, to do some graphical processing. So CPU, GPU, memory, all these we call as resources. These resources are required to run our application. So more the resources, your application will run faster and you will get the results soon. That is the idea. So in the HPC, we have MPI, I told, right? These MPI is libraries. We can make use of many algorithms on these computers, which can solve our problems, high computing requirement problems. Then why HPC? If you see this line, if you have the huge number of computations, three-dimensional arrays, all those things, we can do it very easily in the HPC domain. It is not possible with the serial programming. We need parallel programming with a lot of resources available in the cluster. Usually need millions of time steps, right? So I will show you what are the some of the examples that you are using day-to-day life. Weather forecasting. This is the one thing. Here you will in weather forecasting company, what they will do is they will have huge set of data that has all temperature data, like yesterday what was the temperature, last year what was the temperature, 10 years back. So based on these history results, right, they will predict, they will have some algorithm and predict what will be the temperature tomorrow or next week or something like that. So there will be huge computation here required on the big data, huge data. So we need parallel computing. Each and every pieces of work done by thousands of processes. So it will be faster when it is a parallel. Weather forecasting is the one thing. Then protein folding. Protein folding is about getting the DNA formats, and you can predict some medicines for diseases, all those things. These are very much used in the medical field. Mainly during COVID-19 and all, we used our supercomputers to find some of the drugs that cure COVID-19 also. So very useful in medical field. Turbulence simulation and CFT. Turbulence simulation is movement of air, water, and all. Sometimes in the aircraft and all, we need to calculate, right, turbulence. For that also HPC used. CFT is a computational fluid dynamics. It is extensively used in aerodynamics, then uh, mechanical vehicle simulations, etc. Full body simulation, digital human, lot of things. Basically, wherever you need large number of computation, you should go for HPC. Simple reason, there are lot of resources available, and you are breaking your problem into smaller pieces and doing it parallelly. That's all. Uh, so before going here, I will show one picture. So this is a problem. Uh, just think this is a problem. You have the problem. It will be divided into instructions, smaller instructions. These are the instructions. Okay, your problem is now broken down into smaller instruction sets. Each instruction is, you have three CPUs, CPU 1, CPU 2, CPU 3. Okay, CPU CPU 1 will do some work, CPU 2 will do work, CPU 3 will do some other work. For example, if you have A plus B here, right, A plus B, then C plus D, this is a one calculation you wanted to do. A plus B will be done in CPU 1. I think I like this. C plus D will be done by CPU 2. If I have M plus N, that will be done by another CPU. Finally, I want to add all these things, or I want to multiply all these results. That can be done by reduction operation in HPC terms. What is reduction operation? We will see in next slides. Before that, I want to make clear that bigger problems like this is broken down into smaller instruction sets, all those things. It will do parallelly. If we have submitted to serial way, it would have taken huge amount of time. Now it is parallel. If we increase the CPUs, this bigger problem will be repaired so that your problems will be solved soon, quickly. So I hope you understood this logic where we are using. Now in HPC domain, we are using a MPI library. So there are a different implementation of library. Why I am saying this? Because Google it what MPI download. So basic the main implementations, MPitch, this one, and second. Earlier in and Intel people mod open source and name it as Intel MPI. IBM modified and improved it. These and all proprietary and not freely available. Okay, whatever red colored or green colored. It's me. And so we are concentrated looking at more on open source, whatever the freely available software to run HPC workloads. So one is pitch, that is a older one. Companies are going with the open open API. For example, we had a lot here, adding many other algorithm to the open MPI. So Spectrum MPI is the paid version of open MPI. So it is not available freely, but uh, it is good enough to try with open MPI. It has all the major things that you can you have to try to run this HPC workloads. So let's uh, go with open MPI as of now. And for now, I will pause here and let's install this software so that you can try some hands-on sessions, right? So what I will do is I will install this software. Uh, this is the command. I hope my terminal is visible, black screen. I have shared entire system. If it is not visible, please let me know. Thank you. So I have downloaded this package, OpenMPI, OpenMPI 316. This is the package that we downloaded right now using a wget command. Next, we have to untar this one. I will share these commands with the faculty members. You can try later whenever you are free. So tar is the command to untar. This is a compressed file, right? So let's untar this one. So we have this folder open MPI. If I want to install the libraries somewhere in my preferred location, I have to give the path. So this is the path, NFS, SMP, CA, SACHIN, KLE I am giving right now, so that all binaries and libraries, yeah, it started configuration. Once it is done, make all install. This will create the binaries, libraries, and it will install the uh, open MPI that is required to run HPC workload. Let's wait for some time. It may take 1 or 2 minutes. That's so meanwhile, I'm just throwing some questions to you. In India, right, we have the supercomputers. Usually, supercomputers are owned by big, huge organizations or government companies, right? Uh, do you have any idea where where in India it is located? Are you familiar with any one of the supercomputer in India? Okay, so I have. You can Google search it. Actually, it is a CDAC is a very popular government organization in India. It is known for HPC things. CDAC supercomputer, Param computer, right? It is the first supercomputer they started in 1988. HPC mission they started 1988. Then Param series, lot of Param series, improved versions have come. See, our Indian government is highly dependent on this CDAC supercomputers. For what? These projects, see, BEAM, then Swachh Bharat, Digital India, all Aadhaar card that we have, right? All processing that needs 138 crore people are there in India. So how many people are applying to Aadhaar card, and how fast it is retrieving the data, calculating the right values, and giving you the results. All this possible using these Param computers, CDAC one. This is very popular one, government. Yeah. So let's go to installation part. Yeah, it is completed now. Configure step is completed. Next is make all install. This will install the software. It will create the binaries. It will create the libraries to run big MPA applications. It will take more than 15 minutes. So let it go on in background. We will go to the PPT presentation meanwhile. Yeah. So yes, some of the examples in the human body, they are to identify the cardiovascular diseases, right? For which application, flow of the blood and